This question is serialize and deserialize N-ary tree. So what you should do is you want to serialize a tree and using your own pattern. So this is going to be a pattern that Lico created, but you don't need to follow. And so this is another tree, and you can serialize like this. And I don't know how this pattern is, but I don't really care about it. So comes to here, so you are going to return the string for serialize. Input argument is node, and then when you deserialize, which is what you decode the serialized string, right? And then you return back to the node for deserialize. So just a swap. So let me go through the class of the node. You have the int value, you have the list node children, and you will be able to know how many children for my current root, right? My root has 3, 2, 4, right? Let me use this one instead. So in this one, I have a root. I have the node. Node represent 1, 2, 3, 4, 5. So I have 4 children. Okay, 4 children. And in this children, I don't have. In this child, I don't have what? I don't have anything. But in this one, I do have. So I will. Before I traverse 4 and 5, I want to know 6 and 7, 7 and 11, 14, and once this reaches to the end, then you do the 4, 8, 12, and then 5, 8, 9, and then 13, 10. So that would be the order, the pattern. So the way to do in this is you want to do the pre-order method. So pre-order method, you want to add yourself into the. So for example, I'm doing the serialize. You want to add your node into the list of string first. So this will be a node, and the next one represents how many children for that current node. So I will say current 4. So I will be able to know I will pull 4 times out, and maybe one of them has a children, but at that moment, so I pull 2 out, right? So first one I pull 2 out, and then the next one I will pull 3 out. But if I notice there's 2 children underneath 3, I would do the serialize for this subtree first. So you want to serialize the whole entire tree, but you break it down the problem. If you know this is the leaf, you don't care about it. If this is a subtree, you want to serialize this whole entire subtree before you serialize whole entire tree, right? So subtree might have subtree, right? So you want to just keep serializing, and then you'll do the reverse when you deserialize. So let me stop coding and you'll understand what happened. So if you serialize the string, serialize the method from the node, I will have the list of string to store, right? For the node. And later I'm using a comma separator, so I'm going to say string.join, comma, result, and I will pass in the serialize, and result root. Let's spell this. Okay, I'm spelling correctly. So I'm going to say public void serialize input argument going to be list of string and then also node. So one way of doing the best case scenario is you want to say no if no equal to no. You don't need to do anything, and then later on you will be able to understand how you're going to pattern. So the pattern is you want to add the current node value into a list, then size of children into a list, then you serialize whatever the child, right? So it's going to be result.add, and since node dot value is integer, I need to convert it to the string. So node.val first, and I will say result.add, and then this will represent what? The size of the children, not children, but size. So it has to be what? So it's still string.val, no children.size. And since this is a list of node, right? So I can using the library method to get a size. Then once I know it, I'll be able to traverse the child for the current node. So I'll say node child node.children, right? So based on the current node, the child iteration, and add into my list of string for serialize. Again, you don't want to copy this whole thing again and then changing this and then changing this and then later on you will do another condition checking the grandchild, you know, there's a grandchild has a child, something like this. So you can use whatever the recursion method that you learn. So you can just pass in the result and child into here. So like this will handle the node for the next iteration for the child, and also it will add into the size whatever the current child, you know, subtree has, right? So this is a way to serialize. And then when you deserialize, you will have this value. The first thing is you want to make sure if the data is equal to null, hopefully it's not null, or the length is equal to null, 0, sorry. And then you return null. Okay. Next one, you want to split by the comma. So it has to be string value equal to data.split by comma. And then we will have to so this is what? This is pretty much like a pattern, and we will have to have a queue to basically iterate, how do I say this? Basically, this is a pattern, it's a pre-order method, right? And then we want to make sure this is going to convert into the queue. So now it's a string array, so I will say queue string new linked list, and this and then the size is going to be the value, right? And then we already know what are those value. We can convert it to a list from string array. So queue initialization will be filled out after it's split by comma, and then I can just deserialize the whole entire queue. And then I will say private node deserialize, and then the type will be queue string queue. Okay, so the first thing is we want to make sure the base case, if the queue is empty, we want to return null. Okay, the next one is the first value you add into the the result when you serialize is node.val. The following will be the size of the current node.children, right? So this comes with two ways. First thing is you want to declare a node first, and then let's say the value. So the node.val will become q.poll. Okay, q.poll. However, this is a q.poll is a string type, and then you have integer type. So you want to convert it into integer.parsing. Okay, and then the following one will be the size, right? So in size will do the same thing. So the following value will be the size of the current node. Okay, and this size will be used for iteration. This for loop is literally the same like this, but we don't have the child value yet, so we will do the iteration like this, and then we will apply the same logic. We don't want to copy the whole entire code again and then serialize the child. We were using the recursion method. So before we're doing a recursion method, we need to declare the children, right? So it's going to be list of node for children. So node.children, so node has been declared, right? So node.children will become array list, and then the type is node, and then the size will be exactly the same size when, from here. So you don't get out of bound, you know. And then you'll just basically say node.children.add, and then you pull from the queue, right? But you don't want to just say queue.pull. Like, this is not correct. You want to pull when you deserialize. So you will do this. So you deserialize whatever the next one in the deserialize method. So this will parse the value and then return back to you node. Then you add into the node.children, because node.children is a type this node, right? And then at the end you will return node, because the first thing is when you just got the queue from here, the first value is the root, and then it's a recursion. You're starting from the top, and then you do everything for the children, and then when you're going back, it's a recursion going back, right? Because at the end, queue will be empty, and then you will keep returning node, and then this will come back, and this will become the root, and then you just return. This should be good. Okay, so for the time and space, think about the idea. You will definitely need to traverse all of the node in the tree, and then you will definitely need to save all of the node into the list of string. And then when you deserialize, you are going to create a node to keep adding with your child, right? So when you serialize, it's all of n for the time, all of n for the space, and then when you deserialize, it's still all of n for the time, all of n for the space. So that will be the whole entire solution. Think about this, and then I will see you later. Bye.